Our next question is, what are the properties of indifference curve? First property is an indifference curve has a negative slope or that it slopes downwards. An indifference curve slopes downwards from left to right. In other words, its slope is negative. This property is based on the assumption that if a consumer uses more quantity of one good, he will use less quantity of the other. Then only he will have equal satisfaction from their different combinations. If an indifference curve does not slope downwards, then it can either be a vertical line or horizontal line or upward sloping line curve. It is clear from the following figure. There are four figures. In all figures, on x-axis we take apples and on y-axis we take oranges. First figure is in first figure indifference curve is parallel to y-axis. Second figure indifference curve is parallel to x-axis. Third figure indifference curve is like supply curve. In fourth figure indifference curve is like demand curve but convex to the origin, and this is the right situation. It has negative slope, so it slopes downwards from left to right. In second assumption, second property is convex to the indifference curve is convex to the point of origin. An indifference curve will ordinarily be convex to the point of origin. This property of indifference curve is based on the law of diminishing minor rate of substitution. If an indifference curve is not convex to the point of origin O, then it can either be a straight line or a concave, but it can be proved with the help of these diagrams that on the basis of the assumption of the law of diminishing minor rate of substitution, both these situations are not possible. In this figure, indifference curve is a downward sloping straight line. It signifies that marginal rate of substitution of apples for oranges remains constant. Such an indifference curve can be possible only in case of perfect substitutes. In second diagram, indifference curve is concave to the origin. Marginal rate of substitution of apples for oranges is increasing. But it does not happen in real life. In third situation, indifference curve is convex to the point of origin O. It signifies that marginal rate of substitution of apples for oranges is diminishing. It means as the consumer gets more and more apples, he parts with less and less units of oranges. The consumer gives up 3 oranges for getting one additional apple, 2 oranges for getting another apple, and 1 orange for getting yet another apple. This situation confirms to real life. Consequently, indifference curve is convex to the point of origin. Next property is the two indifference curves never cut each other. It is clear from the figure. Each indifference curve represents different levels of satisfaction, so their intersection is ruled out. In this figure, two indifference curves I1 and I2 have been shown intersecting each other at point A, but it is not possible. Points A and C on indifference curve I represent combinations yielding equal satisfaction, that is, satisfaction from A combination is equal to satisfaction from C combination. Likewise, points A and B on indifference curve I2 represent combinations yielding equal satisfaction, that is, satisfaction from A combination is equal to satisfaction from B combination. It implies that satisfaction from B combination is equal to satisfaction from C combination, but it is not possible because in B combination 3 oranges plus 2 apples, quantity of oranges is more than in C combination 2 oranges plus 2 apples, although quantity of apples in both combinations is equal. Next property is higher indifference curves represent more satisfaction. In indifference map, higher indifference curve represents these combinations which yield more satisfaction than the combinations on the lower indifference curve. This property is shown in this figure. In next property is indifference curve touches neither x-axis nor y-axis. It is assumed in the indifference curve analysis that a consumer buys combinations of different quantities of two goods. Hence, an indifference curve touches neither x-axis nor y-axis. In case an indifference curve touches either axis, it means that the consumer wants only one commodity and his demand for the second commodity is zero. An indifference curve may touch y-axis if it represents money instead of commodity. In it, IC touches y-axis at point M. It means the consumer has in his possession OM quantity of money and does not want any unit of apples. At point N, consumer likes to have a combination of OQ quantity of apples and OP units of money. This combination will yield him same satisfaction as by keeping OM units of money. Indifference curves need not be parallel to each other. As shown in this figure, indifference curves may or may not be parallel to each other. It all depends on the minor rate of substitution of two curves shown in the indifference map. If minor rate of substitution of different points on two curves diminishes at constant rate, then these curves will be parallel to each other. Otherwise, they will not be parallel. Last property is indifference curves become complex in case of more than two commodities. When a consumer desires to have combinations of more than two commodities, say three commodities, then we will have to draw three-dimensional indifference curves which are quite complex. If the consumer wants a combination comprising of more than three goods, then such a combination cannot be expressed in the form of a diagram. In that case, we will have to take recourse to algebra.